And similarly, the next timer program in 8051 is write a program to generate a square wave of 1 kilohertz on transmitted pin, and assuming your FOSC is 12 megahertz. So similarly we will be doing the same configurations, and here we are going to generate a square wave, and here the thing is, for 1 microsecond you will have a clock cycle, and if you have a clock cycle, a positive going will be of 0.5 microsecond and negative going will be of 0.5 microsecond, and your count in terms of x value is 1f4, and if you just give that for in this formula, you will be getting fe0ch, and 0c will be loaded to TL naught and fe will be loaded to th naught, and the same thing what we have applied in the previous program, we have made it here to generate the square wave. And the next topic is serial communication in 8051 microcontroller. So this is your processor, and this is a buffer at a transmitting pin, and this is a buffer at a receiving pin, SBUF. So data will be loaded in the buffer before transmitting, and the receiving data will be loaded in the buffer before moving to any place in the 8051 microcontroller. So for a serial communication, 8051 has two pins, which is transmitter pin and receiver pin at port 3.1 and 3.0, and SBUF registers as given and take data serially in a serial communication on TXD and RXD pins. In a serial communication, first it will send or receive data from LSB and then MSB. So it starts moving from LSB towards MSB. So data will be sent bit by bit from LSB towards MSB. So once it transmits the data, entire data in this SBUF, then it generates an interrupt called TA. And when data receives from external world to 8051 microcontroller, it will be loaded into the SBUF, first LSB followed by until MSB. Once the entire SBUF has been loaded, it generates the interrupts called RI. So this is with respect to the programming aspects. So it starts your 8051 executing the main program, and it has an interrupt TI because over SBUF in transmitting pin. So it goes there, do the service and come back. Finally it clears the TI so that you can store a next byte of data in SBUF for transmission purpose. And this is for RI. So your 8051 executes the program, main program, and once it receives the data from external world to this SBUF register, it generates an interrupt RI. So it goes there, it does the interrupt service routine, and it moves this data to the particular place as per the program, and then it clears the RI. So once it clears the RI, your SBUF will be at the receiving pin will be empty, so that you can expect another byte from the external world to SBUF of RXD pin. So this is how the data will be transmitted from 8051 to external world, and from external world to 8051 microcontroller. And for that we will be making use of this register, which is called SCON, which is serial control register. So again it is bit addressable. So in this, SM0 and SM1 will be utilized for specifying the modes: mode 0, mode 1, mode 2 and mode 3. Under mode 0 it acts as a shift register, mode 1 it acts as a 8-bit UART, mode 2 it acts as a 9-bit UART, and mode 3 it acts as a 9-bit UART, and different baud rates over there. So in mode 0 it just acts as a shift register, sends only data, so 8-bit data will be shifted. In mode 1 it acts as a 8-bit UART, which is universal asynchronous receiver transmitter. So for asynchronous receiver transmitter, you will be having start bit, stop bit. So your start bit is 0 and your stop bit is 1. In between you will be having the bits, 8 bits, which is 1 byte. In mode 2 and mode 3, along with this you will be adding one more bit, which is parity bit, to ensure the data received is correct or not. So SM2 will be utilized. If it is 1, you can have a multi-processor. So if you want to interface 2 or 3 8051 together, then you can make use of this SM2 bit, and if you made to 1, you can interface multiprocessor system. REN is receiver enabled, so it is 1 for receiver enabled and it is 1 for receiver disabled. And TB8 is a transmitted bit 8, and technically it is a programmable 9th bit in mode 2 and mode 0, mode 2 and mode 3. So mode 0 is won't be utilizing this particular bit, and for mode 1, so it is a stop bit 1, and for mode 2 and 3 it is a parity bit programmed by the programmer. Similarly, for receiving, RB8 is a received bit 8, again it is programmable by the programmer, and it will be utilized in mode 2 and 3. And mode 0 we won't utilize this bit, and for mode 1 we will be utilizing this for stop bit, and for mode 2 and 3 parity bit which will be programmed by the programmer. So RI is a receive interrupt, so it will be 1 after SBUF receives 8-bit data. So once the 8-bit of data has been received and it is stored in SBUF, it generates an interrupt called RI, and then it will go to ISR program and it will move the data from that particular place to the specified place in the ISR. And TA is a transmit bit, so it is 1 after SBUF at the transmitting pin. So once this SBUF has been filled, it generates TA, which creates an interrupt, and after that the 8051 will go for an ISR and it will move the data to the external world specified, and then it clears TA. So this is the order specification for a serial port communication. So RX and TX is a pin at 8051, and your sub D9 is here it is a female pin, it will be at your PCs. So if you want to transmit data from 8051 to PC, we require max 232 over here. The reason is the output of your 8051 will be of TTL level logic, but the input required for DB9 pin over here is RS232 levels. So here it will be of 0 volt and 5 volt, but the required voltage here is of plus 3 volt to plus 25 volt and minus 3 volt to minus 25 volt. So if it is of 0 volt which is coming out from this particular 8051 microcontroller, that will be converted into voltage levels from minus 3 plus 3 volt to plus 25 volt. If it is 5 volt which is equal, which is of logic for logic 1, that will be converted to minus 3 volt to minus 25 volt by using max 232. So it will act as an interface and it converts TTL level logic to RS232 level logic to establish a serial communication between 8051 microcontroller to PCs. And the last topic is interrupt in 8051. So in 8051 we have 5 interrupt, all are vector interrupt. So 2 hardware interrupt in that, INT0 and INT1, and 3 software interrupts are there, and 2 is TF0 and TF1, which is timer overflow interrupts, internal interrupt, and 1 serial communication internal interrupts, and that is it may be either TI or it may be RI. So all the interrupts are controlled by 2 registers, which is IE and IP. It is shown over here. So it starts executing the program. Once it experiences the interrupt, it pushes the current next address to the stack, and it go for inter-service routine. And after that, it comes back. It takes the stored address in the stack, and it starts executing the main program. So this is a priority of this 5 interrupt. As I told, INT0 is 5 high priority. Next highest priority is TF0, and next is INT1, and next is TF1, and next is serial interrupt RIR TI. So here interrupt priority register PX0 specifies INT0, and PT0 specifies TF0 interrupt, and PX1 is for INT1, and PT1 is for TF1, and PS is for serial interrupt, and PT2 is reserved. So here if you want if the 80 want to experience all the interrupt at any time, you can make all these 5 interrupts 1, right, or it will be 0 always. If there is an interrupt from any of these 5 interrupt, it will be made 1. So and again it works with priority. To have a high priority, you need to make that to 1, and if you have a low priority, you need to make that to 0. And next is interrupt enable register. So here if you enable this EA to 1, it enables all the interrupts over here, or else if you want to enable in specific, you can make use of this in specific. EX0 is enabling the INT 0, ET0 is enabling the specific interrupt TF0, EX1 is specifically enabling INT1, and ET1 is specifically enabling TF1, and ES is specifically enabling serial communication interrupt, and ET2 is reserved. So if you want to have everything enabled, and you can do just by making EA is equal to 1, or else make EA 0 and then enable everything. Since it is bit addressable, you can enable a particular interrupt as per wish.